If you look up at the night sky and you time it just right, you might get lucky someday and see Mars or Jupiter or maybe even Saturn. But Neptune, you'll never see it without a telescope. It's 30 times farther from the sun than Earth is, so it's way out there in the cold, dark edge of the solar system. We've learned so much about the planets closer to us, but because of this distance, Neptune still has tons of mysteries. And the things we do know came from the only spacecraft that visited it, Voyager 2. And when Voyager 2 looked at Neptune, it saw a world of extremes. It saw supersonic winds, massive storms, and fine dusty rings that are next to impossible to detect. And what's cool about Neptune 2 is the way it was discovered. Back in the mid-1800s, astronomers were studying Uranus when they noticed it wasn't quite moving right. Its orbit was a bit irregular, almost as if there had to be something else tugging on it. So they did the math and found the exact spot where a planet should be, and Neptune happened to be right there as predicted. It's the only planet found from pure mathematics alone. I talked a little about the extreme winds and storms, so let me elaborate on that some more too. So Neptune has wind speeds that reach 2,400 kilometers per hour, which is faster than the speed of sound. On top of that, Voyager 2 saw something called the Great Dark Spot back in 1989. It's a storm the size of Earth, but when Hubble looked at it years later, the storm just vanished. With Neptune and Uranus being so close to each other in size and composition, you would expect both planets to be similar, but Uranus has winds reaching only 900 kilometers per hour. For Neptune, it's 3 times that amount. We think the reason here is because Neptune radiates a ton of internal heat, while Uranus barely emits any heat at all. And outside of just heat, the pressure inside Neptune is incredibly dense. At its core, pressure reaches 7 million times the pressure we experience here on Earth. At those pressures, methane breaks apart and forms diamonds. This means that Neptune could have oceans full of liquid carbon with diamond icebergs and even diamond rain falling like hailstones. How incredible is that? And I'll keep the fun fact trivia going here. Neptune's rings exist in clumps that shouldn't exist in a stable system. They should have just fallen apart by now, but they still maintain that ring structure. It also has 16 confirmed moons, and you've probably heard of Triton, its most well-known moon. Triton contains 99% of all the mass orbiting Neptune, making it the 7th largest moon in the entire solar system. It's bigger than Pluto. And here's the weird part, it orbits backwards. Every other large moon in the solar system orbits in the same direction its planet rotates. Triton does the opposite. That alone tells scientists it didn't form around Neptune. The leading theory is that Triton is a captured dwarf planet from the Kuiper Belt, possibly one that once had a companion moon. Neptune's gravity likely disrupted the pair, flinging one away and capturing Triton. Triton's surface is covered in nitrogen ice, streaked with reddish material. There are surprisingly few craters, suggesting the surface is still active, possibly reshaped by cryo-volcanoes. Scientists also think Triton may have a subsurface ocean of liquid water beneath its icy crust, kept warm by radioactive decay in its core. If that's true, it raises the possibility, however strange, that Triton could support some form of life. And that's the frustrating part. We know so little about Neptune and Triton because we simply haven't gone back. No missions are currently confirmed, although China has proposed a Neptune probe that could launch as early as 2033. Until then, we're left with occasional glimpses from Hubble and JWST, slowly piecing together clues. Neptune is a final frontier of our planetary neighborhood. It's the hardest world to reach, the least explored, and maybe the one with the most secrets still hiding inside. Thanks for watching.